Hi, ladies and gentlemen. Notes 5.3 are on converting equations from vertex to standard form. So let's take a look at the first question that we see here. So it asks us to use Desmos to graph each equation below. So let's go ahead and do that and see what we end up getting. So our first equation says y equals x minus 2 squared plus 1. So it's this red graph that we see right here. Okay, and our second equation is y equals x squared minus 4x plus 5. And if you notice, if I were to look at what I have here, it's blue now because the blue graph is covering the red graph because they're the exact same graph. So regardless of which graph I'm looking at, they're exactly the same graphs. Okay, so for right here where it says, what do you notice about the two graphs? You should say that the graphs are the exact same parabola. Okay, so we can say that the graphs are exactly the same parabola. Okay, so now we need to know about the different forms for quadratic relations, and this is stuff you know from last unit, but we're still going to write some important information down right here. So vertex form is always going to be y equals a times x minus h squared plus k, and don't forget that h comma k is going to be your vertex, and that's really important that you know that. Okay, now standard form you're also familiar with. It's just y equals ax squared plus bx plus c. Okay, and standard form is going to give us some really good information. So I just want to show you guys a couple examples of some parabolas that we will have using Desmos, so you can see what information the standard form is going to give us. So up here we have y equals x squared minus 4x plus 5. And if you notice right here, sorry, let me just fix this really quickly. And if you notice right here, one of our important values we have here is the vertex is 5. So if you look right here, our vertex is the same number that we have right here. So let's try another one. Y equals x squared minus 9x plus 2. So if you look right here, if I look at my parabola, if I were to look at my vertex, or sorry, my y-intercept, it crosses my y-axis at 2. And I apologize, if I said here that the vertex is at 5, I did not mean to say that. I meant to say the y-intercept is at 5. Okay, let's take a look at another one. If we have y equals negative 2x squared plus 7x, if you notice right here, the y-intercept is at 0, and our c value here is also 0. Okay, so one thing that's really important that this format tells us, the standard form tells us, is that the y-intercept will happen when at 0 comma c. Okay, and that should make sense to you because the y-intercept is always going to happen when x is 0. Okay, it will always happen. So write this down, always happens when x equals 0. So for example, if I were to plug in 0 into my equation, y equals ax squared plus bx plus c here, it would be y equals a times 0 squared plus b times 0 plus c. So I just plug 0 in for x. Well, anything times 0 goes away, it cancels out. So all of those numbers cancel out, and I just end up getting y equals c. All right. So let's go ahead and expand to number 1. So right here, I'm going to distribute the negative 3 to both terms that we have here. So when I distribute the negative 3 to the 2x, I get negative 6x because 3 times 2 is 6. And I just bring the negative along. And then here, negative 3 times positive 3 is negative 9. So this is what I get when I expand it. Okay, if I were to expand x minus 2 times x minus 2, I have two choices. I can FOIL it, or I can use the box, whichever you prefer. So let's go ahead and use the box right here. So I've got x here, negative 2 here, x here, negative 2 here. So x to the power of 1 times x to the power of 1 is x squared. X to the power of 1 times negative 2 is negative 2x. Here, negative 2 times x is negative 2x. And then lastly, negative 2 times negative 2 is positive 4. Okay, this is just review from what we learned in the last video. And we know that negative 2x's go together, so I end up getting x squared, and then negative 2 plus negative 2 is negative 4. So I get x squared minus 4x, and then plus 4, and that's my answer right here. Okay, now for this last one right here, I need to expand the x plus 3 first. So I'm going to say x plus 3 times x plus 3. Okay, so I'm going to make a box that's 2 by 2 for x plus 3 times x plus 3, and then I'm going to go from there. So right here, x to the power of 1 times x to the power of 1 is x to the power of 2. Right here, x times 3 is 3x. Here, 3 times x is also 3x. And then lastly here, 3 times 3 is 9. So then I can put the x squared down because nothing is like it. The 3x and the 3x can go together, so I get plus 6x. And then here I just get plus 9. But there is this negative 2 out in front right here. So I can't forget it. So I'm going to write negative 2, and then I'm going to put brackets around this right here. And I'm going to distribute this whole thing through. So I get negative 2x squared, and then negative 2 times 6x is negative 12x, and then negative 2 times 9 is negative 18. And that's my answer right here. Okay? All right, so now let's go ahead and talk about question number 4. It says, write the following quadratic relations in standard form. So first of all, just to look at this right here, by looking at this equation, I can see that the vertex of my parabola is going to happen at negative 6, because remember, it's always the opposite number here. And then it would be negative 6 and then 0, because nothing is being added on right here. So I know that's where my vertex is going to be. Now I'm going to expand it so it's in standard form, so it looks like ax squared plus bx plus c, no brackets at all. So I'm going to expand this x plus 6 times x plus 6. So when I expand it, I'm going to have, let's write out that this is x plus 6 times x plus 6. So I'm going to have an x here, a 6 here, an x here, and a 6 here. And this is x to the power of 1, x to the power of 1. So when I do this right here, x to the power of 1 times x to the power of 1 is x to the power of 2. Then here, x times 6 is 6x. Here I've got 6 times x, which is also 6x. And then lastly, I have 6 times 6 over here, which is 36. So I get 36 over here. So that means that my equation here is going to say y equals, and then the x squared gets copied down. The 6x's get put together, and I get plus 6, or sorry, not 6x, because 6 plus 6 is 12, so this should say plus 12x. And then lastly, we have a plus 36 at the end. So this is our answer in standard form. Now remember, our y-intercept, we wrote down right here that our y-intercept is always going to be at 0, c. So my y-intercept will happen at 0, 36, because this right here is my c value. So let's go ahead and open up Desmos. And I'm going to graph out the original one that we have here and the new one, and I'm going to compare them to each other. So the original one that we have is y equals x plus 6 squared. And if you look at it right here, this is what my graph looks like, okay? And then for my equation that I got here, it's y equals x squared plus 12x plus 36. So I'm going to say y equals x squared plus 12x plus 36. And if you notice, the purple covers up the orange because they're the exact same graph. So regardless of which one I click on, they're exactly the same. Now my vertex happened at -6, 0, like we said, and the y-intercept happened at 0, 36. So we can get all of this information that we need algebraically, okay? So now let's take a look at question number 5. So for question number 5 right here, what we're going to need to do right here is identify what the vertex is to begin with. So our vertex for question number 5 will end up being +7, +4. Okay, now I need to expand this x minus 7 squared. So let's go ahead and do that. I'm going to expand x minus 7 squared. So I've got x here, -7 here, x here, -7 here. So when I do this, x to the power of 1 times x to the power of 1 is x to the power of 2. Then I've got x times -7, so I'm going to get -7x right here. In this box, it's -7 times x, so I get -7x. And then in this last box, it's -7 times -7, which is +49. Okay? Now, if you guys notice, right here, we have -7x and -7x are like each other. I can put them together. But before I do anything else, I'm going to recopy this whole entire equation down. So it's y equals -2 times x minus 7 squared plus 4. But if you notice right here, this x minus 7 squared is what we have right here. So I'm going to copy down the x squared. The -7x and the -7x go together and you get -14x. And then you can just copy down this plus 49. I'm going to close my bracket and then I'm going to add 4 to it. Okay, now what I need to do is I need to distribute this -2 through. So when I distribute this -2 through right here, I end up getting y equals -2x squared, and then -2 times -14 is +28x, and then -2 times 49 is -98, and then I'm going to copy down this plus 4. So then this -98 and this plus 4 are like each other. So I end up getting right here that this equation is going to say y equals -2x squared plus 28x. And if I were to put -98 and +4 together, I get -94. And this is my answer when I have expanded it. So let's go back to Desmos and let's check to see if our answer here is the same thing as our answer here. So let's go ahead and look and see what we have. So the first thing I'm going to do is I'm going to type in the original equation that we got in number 5. So the original equation says y equals -2 times x minus 7 to the power of 2 plus 4. Okay? And if you look, this is what we end up getting right here. Okay, now let's type in the other one, y equals -2x squared plus 28x minus 49, or sorry, minus 94. And if you notice, they're exactly the same. They're exactly on top of each other. And the vertex was +7, +4. Now, let's look back at what we have here. So if I look at what we have here, our y-intercept is going to have to be at C, and here my C value is -4. So my y-intercept is 0, -94. So let's go ahead and look at Desmos, and we'll have to scroll down quite a bit in order for us to see our y-intercept. And if I look at my y-intercept right here, it is 0, -94, so it works for us. Okay? All right, awesome. We have one more to go. So in question number 6, this time it says a parabola with a vertex at 5, -8 with a vertical stretch of 3. So if you remember, our general equation is y equals a times x minus h squared plus k. And here I can say that the a value is 3 because there's a vertical stretch of 3. So I'm going to say y equals 3 times x, and then here the h value is 5, so I'm going to say x minus 5 squared, and the k value is negative 8, so I'm going to say minus 8. So now I'm going to expand this piece right here. Okay, so it's x minus 5 times x minus 5. So over here we end up getting x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is also negative 5x. And negative 5 times negative 5 is positive 25. So then what I'm going to do is I'm going to recopy down this full equation that we have here. So it says right here, y equals 3 times x minus 5 squared minus 8. But now we know that this x minus 5 squared is what we got right here. So I end up getting y equals 3 times, this x squared just gets copied down. The negative 5x and the negative 5x go together, so I get negative 10x. And then I just copy down this plus 25, and then I'm going to subtract 8. So I end up getting here y equals, distribute this 3 through to everybody. So I end up getting 3x squared minus 30x plus 75 minus 8. So now this 75 and this negative 8 are like each other, so I can put those together. And when I do, and then this gives us plus 67. So therefore my y-intercept would be at 0.67. So let's again use Desmos to double check to make sure that we did this correctly. So I will type in y equals, so move this over right here. We'll close out of that, and here we'll say y equals 3 times x minus 5 to the power of 2 minus 8. And I'm going to adjust the zoom so I can see things a little bit better. And it does have a vertex at 5, negative 8, which is great. That's exactly what we need. And then let's type in right here, y equals 3x squared minus 30x plus 67. And they are right on top of each other, so that's good news. And then if I scroll all the way up to 67 right here, I'm going to see that my y-intercept is at 0.67. So I'm good to go for that question, and that's all I need to do. All right, guys, I hope you have a great day. Let me know if you have any questions. Keep up the awesome work you're doing, and I will see you soon. Okay, bye.